In this video, I'll be talking about, now we're going to start bringing in our graphs of our exponential and log functions, but focusing on the domain and range. So here, remember, you could have an exponential as that base being raised to the x power, or also even e being raised to the x power, right? Because remember, that represents our natural log. So here in example one, or the inverse of that. So here, like in example one, here's a graph of 3 to the x. Now, notice here too that we are now going to bring back our asymptote because here our graph is approaching but never reaching this asymptote here, which is the x-axis, right? Or at that value of 0. Now here, notice the domain, right? Think about domain as that left and right. Well, notice the graph is constantly going to the left and constantly going to the right. Yes, it's going up, but it's getting wider and wider and wider, which means the domain is all reals, right? So from negative infinity to infinity. Then the range, so now notice the range though, because that's your y values, right? That's your up and down. Well, notice the graph is only above this asymptote. It gets closer and closer, but never reaching that value of 0. So that means here that our range values are y are, because above, greater than 0. Now notice here too, we're just going to put greater than, not greater than or equal to, because we're not including. It's never going to reach 0. So it's strictly the y values are greater than 0. Or in this case, you would see it as 0. Notice the parenthesis because we're not going to include it, to infinity. So you could see that range either way. So go ahead and pause the video and try this. You try on your own. And here we go. So now notice our exponential graph here, all right? So again, we have that asymptote where the graph is constantly approaching, but never reaching this value of 0. Now the graph is constantly going to the right, constantly going to the left here. So this domain is also, again, all reals. However, the range, there's that cutoff, right, because of the asymptote. So we have a y and greater than 0. So notice how here, even though this showed growth and this showed decay, no matter what, you still have in the exponential that horizontal asymptote and the graph approaching that asymptote, which is cutting off our range here, the y values. So now here, notice how we have an exponential. It's been shifted, right? And also it makes sense too here because we shifted up 4 units is what this transformation is showing us. So again, here we have this asymptote. The graph is approaching, right, but never reaching this asymptote here. But again, constantly going to the left, constantly going to the right, getting wider. So the domain is all reals, negative infinity to infinity. However, the range, now notice, our range is approaching this value of, that y value of 4. Notice how the y values, the function is below that asymptote. So this is now less than 4. Remember, not including because that's our asymptote, approaching but never reaching. So you could also see this as negative infinity to 4, and again, use parentheses because we're not including that value of 4. So now go ahead and pause the video and try this. You try here on your own. And here we go. So again, notice how we have that horizontal asymptote, again, approaching but never reaching this y value here at 3. So notice how with that y is equal to 3 here, that's your asymptote. So that means my domain, again, is all reals, right? Because we're going constantly left, constantly right. But the range we have here is not all reals because the graph is above a value of, oh, and I just realized I put 3 here, guys. Sorry about that. That is negative 3. And that also matches because our transformation shows on the outside we went down 3. And again, above, so the range is greater than negative 3, or again, negative 3 to infinity. Then so same thing. What if you had a base of e? Well, again, notice we have that horizontal asymptote. approaching or never reaching that value of y is equal to -1, which also matches our transformation here, right? -1, so we're going down 1. Same thing. Notice how the domain is all reals, right? Because we're going constantly to the left, constantly to the right. And notice again how the range or the y values are not all reals because of this horizontal asymptote. So we've got y's. Again, we have that -1 here, and our graph or functions are below that -1 here. So we have values are less than -1, or again, negative infinity to -1. And again, using parentheses because we are approaching. So go and pause the video and try this. You try on your own. And here you go. So again, we've got moved up to, right? And that matches because of the, and with that asymptote, horizontal asymptote, matching our transformation going up to, we are approaching, but never reaching that y value here at negative, at y is equal to 2. So again, the domain is all reals, negative infinity to infinity, but our range values, y values, are greater than 2. Notice how our function is above and approaching but never reaching. Or again, you could have put 2 to infinity because all the values are greater than 2. So now with our log, now notice the log, remember, right, is the inverse of our exponential. So here in this example, now notice we have this vertical asymptote here, approaching but never reaching. And so our log function, our graph, notice how it's constantly going down. It looks like it's kind of getting, but it's constantly going up. So with that up and down direction now, that is our y values, which is our range. So now our range is from negative infinity to infinity. Now the domain, remember, was the left and right, but notice how because of our asymptote here, right, at x is equal to 0, because it's approaching but never reaching, now our domain is not going past this, right, and it's not going all the way to the left. So the x values are starting at that asymptote of 0 and constantly going to the right, which is greater than. Or you could also write this as 0 to infinity. So now notice here we have that asymptote approaching but never reaching 0 and constantly going to the right towards positive infinity. Come pause the video and try this. You try on your own. And so again, notice here we do have that asymptote at x is equal to 0. So we do have that vertical asymptote. And notice again how the graph is constantly going up and constantly going down. So that's your y value. So the range is all reals, or negative infinity to infinity. However, the domain, though, because of this asymptote, is not going past 0 into negative, right? So x's are greater than 0, because even though we're going down, this graph, our x values are constantly going to the right to positive infinity. So again, this is 0 to infinity. So now with example 5, notice how here we do have that shift, which makes sense here, because notice how now we have a vertical asymptote where the graph is approaching but never reaching at that value of x is equal to 3. And notice how here on the inside, right? Inside was always our horizontal, which was opposite. So even though it says x minus 3, we're going to the right 3. So that also matches. Then again, notice here, even though with that transformation, our graph is constantly going up and constantly going down. So the range is all reals, or negative infinity to infinity. However, now notice our domain, the x values, are constantly starting here in the negative values, but now constantly approaching but never reaching, never going past that value of 3. So now all of our x values, the domain, are less than 3, or negative infinity to 3. Because remember, right, we're starting here, our x value is starting at -3 and approaching but never reaching 3. Now go ahead and pause the video and try this. You try on your own. And here you go. So again, notice how you have that vertical asymptote. We're approaching but never reaching this value, this x value here at 2. And that means the domain, right? So the domain is starting at that value of 2, but constantly going to the right towards positive infinity. So x's are greater than 2, or you could have written 2 to positive infinity. And then the range, well, it's constantly going down to negative infinity, constantly going up. So again, the range is all reals. And then so in our last example, 6 here, notice how again, even with a natural log, it's still our logarithm. We have that vertical asymptote. So notice how our graph is approaching but never reaching x is equal to 1. So now notice here how we are constantly going down and constantly going up, so the range is still all reals. But the domain are x values. They're not constantly going to the left here towards negative infinity because they're starting here at 1 and constantly going to the right towards infinity. So x's are greater than 1 or 1 to infinity. So go ahead and pause the video and try this. You try on your own. And here we go. So again, same thing here. Notice how we have that vertical asymptote where here our values are approaching but never reaching. X is equal to -4. So that means the domain, and again, so we're starting all the way over in negative infinity now and approaching but never reaching -4. So x's are less than -4. Or you could have written sorry about that. You could have written negative infinity to -4, but the range is still all real.